medical diagnosis as applied in artificial intelligence. In artificial intelligence, sorry, I don't forget to introduce myself. I'm Bill Cheptoyek, a student at Makerere University, and I just want to tell you medical diagnosis. This is quite a problem. It's quite hard to determine what sickness a patient is suffering from. Sometimes even doctors whom we think are so good make big mistakes when diagnosing patients. For example, there is a situation where a patient, Ted Blackwell, was misdiagnosed by doctors from a Kaiser clinic in California with headache. Actually, he had just lost his brother 8 days before the diagnosis, and this doctor diagnosed him. These doctors diagnosed him with stress, that the stress had caused the headache, yet in actual sense it was cerebral bleeding he was actually suffering from. Imagine he had lost his life because of this misdiagnosis. He wasn't diagnosed with the sickness he was actually suffering from. It's really a big problem. But just know, if we were to use artificial intelligence, we could quickly solve this misdiagnosis problem and we would save a lot of lives. And I'm going to concentrate on prostate cancer as an ailment, how it can be diagnosed using artificial intelligence. And I'm going to use this data set. Artificial intelligence will improve the accuracy of medical diagnosis with casual machine learning. Here is something that is quite self-explanatory. You get the clinical data, for example, the prostate cancer diagnosis of previous patients. Let's say there are signs and symptoms, what they have been going through, then the treatments, all those details got, and using machine learning, the AI is taught, and then the diagnostic model designed so that we could easily do this without needing doctors to do it. So these are the factors that I considered to select this dataset. The dataset should have enough data so as to prevent class imbalance and curating the test set. And it should be reaching a consensus among data labeled. Yeah, like it should be labeled in a consistent manner so as to prevent having problems within your data. Like it should be similarly labeled so that your AI can easily read through and understand and learn. Data security and discretion are also factors to be considered. Yes, the data must be secure. It should not be tampered with, and also ensure that data is independent and identically distributed. These are important factors I considered. Important features in my dataset. My dataset contains a few signs and symptoms of prostate cancer. It contains examples of patients that have suffered from prostate cancer. It contains a report on the various cases of prostate cancer patients. It also contains treatment details of the patients. how they were diagnosed, and so on. It also contains a prostate specimen. As you see, if you click on the link that you at my reference, the last one, here, the Bayesian theorem. It is a branch of artificial intelligence, and it deals with the use of Bayesian interface to make predictions. Yes. It's defined as the likelihood of a specific event occurring in the future if a previous outcome had occurred in the past. Probability, right? Yeah. Bayesian theorem continued like, yeah, in machine learning, the Bayes theorem can be used to create classification models for training data and to fit a model to the training data set. For example, if cancer corresponds to one's age, by using Bayes theory, we can determine the probability of cancer more accurately with the help of age. Naive Bayes. It's based on Bayes theorem and assumes independence among predictors. In simple terms, Bayes classifier assumes that the presence of a particular feature in a class is unrelated to any other feature. That's more naive Bayes. Then there's also the Bayesian network. Its other name is the belief network, or you can call it the causal network. It is a probabilistic graphical model which represents a set of variables and their conditional dependencies using a directed acyclic graph. The Bayesian network contains nodes and edges. It shows probabilistic relationships between the ailment and symptoms. This is as used in medical diagnosis. For example, the network can be used to calculate the probabilities of existence of various diseases. Here, there is a difference, and you shouldn't confuse the difference between Bayesian theory and naive Bayes. Bayesian theory does not assume conditional independence, but naive Bayes does assume conditional independence. And then there's also a difference between naive Bayes and Bayesian networks. The naive Bayes assumes conditional independence, but for the Bayesian networks, it allows the user to specify attributes that are conditionally independent. I hope you get that. It's less the naive Bayes is less complicated compared to the Bayesian networks. And here are a few references if you want to know how I got this or more details about this. There is the Bayesian network classifiers. Then there's this link that is going to give you more details on the Bayes theorem for machine learning. This can give you more details on naive Bayes. And this this is a book called The Global Burden of Diagnostic Errors in Primary Care, the prostate diagnosis metadata. This is my data set if you want to check it out. Yeah, and